All right, let's check this question. Okay, in the year of 2008, there were 507 children in Arizona out of 32,601 were diagnosed with autism spectrum. Okay, let's check the number. 32,601, 507 were diagnosed as autism, and nationally, here is the small proportion in Arizona, Arizona, and the national, the proportion 1 in 88, 1 in 88. So can you see the difference here? Sorry, my handwriting is horrible. I know. Arizona, 507 divided by 32,601. What's the ratio? Sure. Okay. And now test at 1% level. 1% level. 1% level, that is alpha equals 0.01. So far, any question? We can imitate the previous one. That X is the proportion. Now we need to calculate whether the number is close to the national. Thus, we have that the non-hypothesis, the p-height, the proportion in Arizona, the proportion is the same as 1 over 88. Sure, 1 over 88 we can calculate. That would be 1 over 88. That would be 0.11363636. Maybe how about we can get this one 1136. Then we can calculate this. And how about the alternative hypothesis? The proportion of the children in Arizona, the proportion is greater than 1 over 88. 1 over 88. And now we can check NP should be greater or equal to 5. Let's calculate N, the population. So how about the N? Should I use 32,000 or 507 as the N? Who can tell me? I'm going to calculate NP, the NP that you can review the previous. Here. Here, okay. To determine the sample distribution of p-height, you need to show that NP greater or equal to 5 and that NQ greater than or equal to 5. And now what's the N? N is the sample or the children who have been diagnosed as autism. The N here. Sorry, I forgot. Okay, N is the number. N is the number. Okay, let's move to the next question. Thus here the N, that would be, sorry, 32 601 times the proportion 0.1136. 0.1136. Sure, from the calculation, we don't need to calculate. It must be greater than 5. How about the others? The other N times Q should also greater than 5. Let's check. 32,601 times 1 minus 0.1136. Sure, absolutely. Here is about 0.9, 0.8, 0.9. Here 32,000. The answer must be greater than 5. Thus, we can say the samples are normally distributed. No problem. No problem. Okay, so what's the next? What's next? Then calculate. Check the formula here. Check the formula here. Then the proportion head, P head, the positive number divided by the sample taken. In this case, 51 divided by 14,495. In our case, here, okay, how? The P head should be 507 divided by 32. 607, I forgot it. So the number, sorry, can you tell me the number? 601. Oh, thank you. So the proportion here, after the calculation, (507) divided by 32601, 0.1555, like this one. Okay. And next question about how to calculate this. We set alpha level is 0.01, and here I use the green. The Z score is P height minus P and square root of number P times Q, and P height, if we take 4 decimals, 1, 2, 3, 4, that would be 0.015 and 6 minus 0.1, sorry, I forgot the number, 1136, okay. And square root of the number 32,601, the P 0.1136 times 1 minus 0.1136. Is it okay for you? Sure. My suggestion is we can calculate this step by step. First of all, okay, about the denominator, that is 0.0042 and divided by square root. 1 minus 0. Divided by so far. Is it okay for you? Okay, then we got the number is here. Sorry, let me enlarge it. Okay, nope, I think it's not big enough. 36. Okay, after the calculation, the z-score is like this. Oh, okay. How do you think about this number? How do you think of this number? Personally, very small than 0.01. Very small than the original alpha level 0.01, right? Then I can say there is enough evidence that the autism in Arizona, the children has been diagnosed that they are autism spectrum disorder is different from the national ratio, much lower, much lower. Is it okay? Yeah, yeah. Here, the calculation. Yep, here. Here. Sorry? Yep, go ahead.
This one is 0.0114, right? But here is 0.11.
Yeah. You're right. You're right.
0.11.
My mistake.
Right?
My mistake. Sorry. My mistake. Yeah. Thank you for the correction. Yeah. Because 1/88 should be greater than should be this you is reasonable. I thank you for correction. Yeah. This one. I will use this one. I thank you for the correction. This one. And here 0.156 is the ratio from the Arizona, and the national is 1/88. 1/88 should be 0.1. Sorry, I misplaced the one more zero over there, and that should be here. So yeah, you know sometimes I always type I may miss some details. Thank you for correcting me. Okay, and thank you for correction. And here should be 0.0 the denominator minus 0.098. Thank you. And then divided by square root okay, is it okay? Then I press the enter and get a number like this one. Very, very small, very small. So we can say that it's smaller than 0.01. And we can reject the non-hypothesis and accept the alternative hypothesis. The autism in children that has been diagnosed, and the ratio is different from the national ratio. Maybe something different in Arizona. I don't know that. Okay, 1 minute. Then we can move to next section. Yeah. Next time, if you find my mistake, please let me know. Don't be shy. Okay, let's move to next question. Chapter 7.3 about the sample mean. And here it's time to get back look about the test of the mean, and that was introduced in section 7.1 called the z-test. In the example, you knew what the population standard deviation, sigma is the population standard deviation, not the sample standard deviation, sigma, okay, was. And now, if you don't know the sigma, how can you do that? Again, if we have enough money, enough labor, enough time, we can find the population standard deviation. But actually, in most cases, we don't have money, we don't have labor, we don't have time. Thus, we estimate a sampling plan. We try to use the sample standard deviation instead to get the population standard deviation. Because we have limited time, we have limited labor, we have limited budget, okay? And now you could just use the sample standard deviation S, the italic S, as a approximation of sigma, and that means the test statistic is now x bar minus mu divided by S divided by square root of n, and great. Now you can go and find a p-value using the normal curve, or can you? It is now test statistical normally distributed. Actually, it is not. How it is distributed? A man named W.S. Gossett and figure out what this distribution is called the student T distribution. It's very famous. I think this gentleman, this scientist, was born in UK, but he got a job from a brewery, a beer company in Japan. In German, and he created the T distribution, and there was a big contribution in the statistical field. There are some assumptions that must be made for this formula to be a student T distribution. They are outlined in the following theorem. Note, the T distribution is called student T distribution because the name he published under before, because he could not publish under his own name due to the employer not wanting him to publish under his own name. His employer, by the way, was Guinness, and Guinness is a very famous beer brewer, and they did not want the competitors knowing they had a chemist working for them. It is not called the student distribution because it's only used by students. Okay, actually, I heard about the story. The student is the pen name of this gentleman. And now, theorem, if the following assumptions are made, a random sample of the size n is taken, the distribution of the random variable is normally the size is 30 or more, then the distribution of t, the x bar, what does it mean x bar? Samples you selected and get the average, we call it x bar. Minus the mu is the samples average, the population average, is the student distribution with n minus 1 degree of freedom. With the n minus 1 degree of freedom. Sure, degree of freedom, I studied some textbooks, and to be honest, it's really hard to understand, very hard to understand. And the denominator s, the sample standard deviation divided by the square root of n, the number of n is taken. Okay, and explanation about the degree of freedom like this one. But if you have a problem understand this, just remember minus 1, n minus 1. Okay, let's move. When degree of freedom, that's 1, that's 2, and standard deviation, generally speaking, the number is increasing, the curve is approaching to the normal distribution. But when the degree of freedom, the number is smaller, the spare shape of the t distribution curve a little bit wider, shorter than the normal distribution. Okay, let's move here. T-test. Okay, t-test is very important for the statistic. Previously, we call that normal test, normal distribution. But now, t-test is another important issue. In the future, you may study some business cases. T-distribution, t-test is very important. Okay, let's check. State the random variable and parameter in words. X, let the x to be the random variable. Mean, mu, the mean of random variables. Okay. The mean, okay, mu is the mean of random variable. State the non-hypothesis and alternative hypothesis. Non-hypothesis, the mu equals mu0, where mu0 is unknown. Alternative hypothesis, mu smaller than mu0, greater than or not equal to. Also state your alpha label. State and check the assumption of random sample n, the number of sample n is taken. The population of the random variable is normally distributed. Again, through the t-test is fairly robust to the condition if the sample size is large. This means if the condition is not met, but your sample size is quite large, over 30, then the result of t-test are valid. Okay. Then the population standard deviation sigma is unknown. Because it's possible to get the number. Find the sample statistic, test statistic, and p-value. The t-test t equals x bar minus mu divided by the n divided by square root of n. Sure, you don't need to memorize it. In the future, I will I will open every tools for you during the exam, with a degree of freedom n-1 and a p-value like this. And now I ask your help. We calculate the number by the calculator, but in the future, I will give some websites. You just type some parameters, then you will get the answer immediately. But you cannot understand the rules, the why we get this answer. Okay, let's move. Okay, a random sample, example 7.3.1. A random sample of 20 IQ scores of famous people was taken from the website of the IQ famous people. The information is from here. A random number of generator was used to pick up 20 of them. The data example is here. Do the data provide evidence that 5% level of the IQ of famous people is higher than the average of 100? Okay, again, we think the population average IQ is 100, and for another special group we call famous people, after the test, how do you think about their IQ? 225. Amazing. Amazing. How can the person gets this kind of IQ? Okay, and here is the number, and state the random variable and the parameter in words. The first one, state that X equals the IQ score of famous people. And can you get all famous people? Maybe thousands of thousands. No, it's impossible. But here, 20 famous people were selected to run this test. Second question, state the non and alternative hypothesis and the level of significance. First, mu0, hypothesis, non-hypothesis, mu is equal to 100. I mean, the average IQ from famous people is the same for the population, for the general people, the ordinary people. And the non-hypothesis mu greater than 100. They are smarter. Set the alpha level at 0.05. Sure, actually, we got this. And now, a random number of 20 IQ scores was taken that was said in the problem, in the question. The population of IQ score is normally distributed. That was shown in here. And now, calculate X bar 145.4, standard deviation is 29.7. And now, please calculate this number first. Can you do that? First of all, I just copy and paste it here, or you can move to the script, the example 7.3.1. One minute later, I will show you how did I do that. Okay, and please go to your Google Drive. Oh, sorry, I forgot to switch the language. 1 minute, please. Okay, and have a new spreadsheet, Google spreadsheet, and name as today's. Like this one, okay, and we just move here, copy, and paste. Is it okay? Copy and paste. Okay, and then calculate the mean. And standard deviation. For example, I click here and click function, or you can type equal, then get the function average. Oh, sorry, let me finish this question. And the number here. Yeah, sure, you can list it in a row or in a column, but now I select them together and press enter. We get a mean, we get an average. Questions? Yeah, if you find any mistake, please let me know. And click enter. Then we can use, oh, sorry, I got lost here. Okay, next part here, that's 145.4. Okay, but my answer is about 140. So do you think which one is correct? From the textbook, the X bar, the sample average is 145.4, but my calculation is 140.05. Pardon me? What's the number? So this. So. The numbers here. So what's wrong with this one?
Yeah. The last one.
Oh, okay. Thank you for the reminder. Thank you for the reminder. It's my mistake. Oh, okay. Thank you for okay. And sure. After calculating 145.4. Thank you for the correction. Okay. And next, how to get the standard deviation? How to get a standard deviation? Here, click equal and use the function. Sure, or you can insert the function about statistics, then standard deviation sample. Either one is okay. Population. Again, select the range, insert, or select range, insert, function, statistic, and select standard deviation. S for population, so for samples, P for population. And now those famous people, they are selected. 20 were selected. So we use sample. It's okay. And got the answer. Sorry. And select range. $29.27. Let's check the answer. 29.27. Okay, the same as the textbook. So far, any question? Okay, and again, I encourage you to do this by the software, but not directly input the number and get the answer. No, I hope you can do this and you can practice how to get the function from the Google spreadsheet. And next question, how to get the test statistic T, the T score, the T number, X bar minus mu. X bar 145.4, mu 100. My question, where does the 100 come from? Where does the 100 come from? Where does the 100 come from? From the question, the question states the average people IQ is 100. Thus, we think the population average is 100. 145.4 minus 100. Then here the S. Example 7.3.1. We know the T, that is X bar minus mu and divided by S divided by square root of N. we know the x bar, that is 145.27. We calculated that from this. Right? We calculate from here. Then the mu is about, I use the color of green, about 100. From the question, the population mean of the IQ is 100. Then the sample standard deviation, we know that we got the 29.27, 29.27, and square root of n. What does it mean, n? The number of samples were taken, that was 20. Thus, this part, that is square root of 20. And now, I encourage you to use the to do this, and here 145.27 minus 100 and divided by 29.27 divided by square root of 20. Okay, then where is my calculator? Where is my calculator? Okay, and press enter, and the number is 6.937. I got the answer, that is 6.9, 6.91. Oh, very close, very close. And the next question. And how can you know? How can the p-value 1 minus this? We need to check another table. How about have a 10-minute break? Then I should go back to the office to do something. Then I will be back. Okay, how about 10-minute break? Then I will continue to solve this problem.